So okay guys, today I'm going to be talking about a very simple and easy to do science experiment called Woosh Rockets. Now Woosh Rockets are a very easy experiment to replicate. All you really need is a barbecue igniter, a bottle cap, and a drill. Now to set up a Woosh Rocket, all you do is just drill a hole in the bottle's lid directly in the center. Now this hole has to be large enough to wrap around your barbecue igniter's diameter pretty much of the shaft. So as long as it can fit around a barbecue igniter, you're good to go. What you do is you fill up the bottle, preferably a soda bottle because the plastic is a bit thicker than a normal water bottle, filled up with some rubbing alcohol, swirl it around a bit, dump out the excess or pour it back into the bottle. What you're really after in this particular rocket example is the rocket or the vapor itself from the alcohol. So shake it around, get it out, make sure there's no liquid pooling at the bottom, screw your lid on, and you can stick it on your barbecue igniter, click the trigger, and your rocket will fly off. Now there are some things you can do to ensure your safety. You can make like a splash shield using a DVD spindle, stick that over the barbecue igniter, put your bottle on, and fire it. That way you don't have to worry about any kind of splashback or anything. However, I took things a bit farther with this simple science experiment. I decided to push it to its theoretical limits. I wanted to try many different nozzle types out. I printed out a few that looked like the actual space shuttle's nozzle. You go from a middle smaller diameter to a much larger one. These printouts will just screw right onto the water bottle, fit any typical barbecue igniter, and they're ready to go. I also provide a splash shield or a launch pad that you can stick on the barbecue igniter's shaft itself. That way if you're nervous about it blowing back at you, you won't have to really worry. That splash shield will protect you. Now, if you're wondering if the plastic itself will melt, well, typically no. I fired these rockets dozens of times, and I still have some of the very first rockets that I ever made that still do work. Typically, the way a Woosh rocket works is at the point of ignition, that's the hottest. So at this point where it sparks inside the bottle is 700 degrees, but by the time the flame comes out as well as the air inside the bottle heating up, it will be pretty much cool to the touch and the bottle will go flying before it ever melts the plastic, nozzles, or the launch pad. Now there are some things to know with these rockets. Sometimes you can fire them repeatedly, one after another, and then all of a sudden they won't work. Once the alcohol vapor is inside the bottle, even though you don't see it, some of it doesn't always ignite. And if you're worried about the environment, alcohol itself, or inherently rubbing alcohol, when it burns, leaves only water behind, so there's no kind of emission from it. Anyway, if you end up firing a few rockets and all of a sudden it ain't working, just swoosh some water in the bottle, dump it out, dry it off, and you should be good to go. Now there are some times where humidity can play a factor, and this is even written in NASA's documentation on the Woosh Rocket science experiment, is sometimes a spark won't occur just because of humidity itself. So if your rocket isn't firing and you've tried a dozen or so out, chances are it's just the weather or your spark or igniter is busted. So check both out, and if that's the case, just wait for another day to do your test. Anyway, again, this is a very simple experiment. It can be done with 3D printing, it could be done without it. However, like I said, I made 3D printed parts, and if you guys want them, they're down below in the description, so feel free to download them and give it a shot. Now, another main reason why I went the 3D printing method with this project versus just drilling holes in lids is you get perfect laminar flow, meaning you can print out multiple lids and you won't have to worry about the aerodynamics of the rocket, because overall it will be pretty much the same. If you're wondering what I mean, take a lid from a soda bottle, drill a hole in it, put some water in the bottle, and dump it out. You'll see that maybe the water coming out is turbulent, but if you 3D print a part, get accurate precision, it won't be as turbulent and will kind of come out in a clear, concise flow, like a laminar flow. So if you're worried that your drilling isn't perfect in the bottle lid itself and you want to get the maximum direction out of it, I guess you should say, you want to check the laminar flow. If your bottle doesn't have water coming out of it smoothly, sand the edges and it's pretty much good to go. But like I said, if you have a 3D printer, you can print out a near perfect nozzle in bulk pretty much. You can make multiple of these versus having to drill holes in multiple different lids and then test them out. But yeah, that's pretty much it for today's video, guys. I hope it was informative and entertaining. I hope you guys got a kick out of some of the b-roll of these things actually going off. But yeah, I think for now I'm going to leave today's video off here. DTPK signing off. Peace. D-pad, I'd rather use an actual authentic rubber D-pad. You could easily do that. You don't need the... Maybe you guys would want to replicate it, make it the correct way that I had in mind or envisioned. So